Hey guys, me again. Today I want to talk about relays. So this is a double pole, double throw relay. It activated a 12 volt or 24 volt direct current or DC voltage. So let's get into it. So your power would get connected here to positive plus and your negative minus. And then here's one relay. Here's one set of contacts. Here's the other set of contacts. This one relay controls both sides. So whatever happens to this relay is going to happen to both sides. That's what a double pole, double throw contact is. The double pole means there's two sets of contacts. The double throw means there's a normally closed and a normally open side, an NC and an NO. And it's the same on both sides, common, normally closed, normally open. Let's test it. So you get yourself a power source right here, and we'll connect it. Get yourself a screwdriver. So the first thing you want to do on this is determine what's your positive, what's your negative. And if you watch my other video, you can do that with your multimeter. We're going to put it on DC, direct current, and we'll find out which way, which lead is what. So right now I have 12.24 volts DC. So this is the correct way. If I was backwards, it would read negative. So that's negative. So that means it's backwards. If you look closely on this wire, it's hard to see, but this wire, one has a stripe on it, one doesn't. So the striped wire is actually my negative. So let's see what happens. I don't know if you can hear that. That's the relay firing. So let's take our meter and put it on the continuity tester, which is this sound, which if you watch my other video, you know we can test continuity with that setting, and that tone means we're a continuous circuit. So what we want to do is use this to find where when this is sitting in a non-energized state, there's no power going to it, what does everything read? So you have your common, you're normally closed and normally open. Common is a fixed point. What will change is the normally closed and the normally open. And I'll show you what I mean. So if for this video's sake, we'll say common is black, always black. So if I hold my black lead on common and my red lead, we're going to find out where the circuit is continuous in the state where there's no power. So that's the normally closed, NC. If I take my red lead and move it to normally open, I get nothing. We'll test the other side. My black on C for common, my red on normally closed, I get the tone. Continuous circuit, no power, I'm getting, my circuit is not broken if I use the common and normally closed part of the relay. If I move it to normally open, nothing. So these are two separate entities. They do not cross each other. And I'm going to prove that to you. I'm going to put one leg on the common on this side and normally closed on this side. I get nothing. Same thing if I put common here, normally closed here, nothing. And then also to show you that the fixed point is common, I will put my leads on normally closed and normally open. These points should never have tone or that sound. If they do, your relay is most likely damaged. So now let's land this power supply to negative and see what happens. We're going to hear the relay change state. Tighten this down. We know that in the unenergized state, common and normally closed, we're giving us a continuous circuit. Now, if I test common and normally closed, I get nothing. But if I use common, normally open, I get tone. We'll test the other side. Common, normally closed, nothing. Common, normally open, tone. And that is how you can test a relay and how it operates. And I'm going to make another video, link in the description, about how I use a relay, not this kind of relay, but how I use a relay to have my Alexa device control my gas fireplace. Keep it simple, baby.